December 1943. In a frozen Belgian forest clearing, a German panzer commander stood atop his Tiger tank, binoculars trained on two American infantrymen crouched behind a burned-out half-track. He laughed, a short, dismissive bark that his crew could hear through the open hatch. The Americans carried nothing but a crude steel tube, something that looked more like plumbing equipment than a weapon. Within 20 meters, that laughter would turn to screaming, and the Wehrmacht's arrogance about Allied infantry would die with the flames of a 60-ton machine. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The early morning of November 10, 1942 began with chaos on the Algerian coastline. Captain Thomas Ridgefield of the 1st Armored Division crouched behind a stone wall, his uniform still dripping with seawater from the landing craft. Around him, young soldiers from Kansas farms and New York tenements scrambled through the dust, clutching rifles they'd barely fired outside training ranges. But scattered among them were wooden crates marked with stenciled warnings, classified ordnance, handle with extreme care. Ridgefield had been briefed exactly once about the contents, 3 days before embarkation, in a canvas tent aboard the troop transport. A colonel he'd never seen before had stood before a covered object and spoken in clipped, urgent sentences. "Gentlemen, you are about to receive a weapon that will change infantry warfare. It has never been combat tested. You will have no manuals, no training time, and no second chances to learn how it works." When the colonel pulled away the canvas, Ridgefield had stared at what looked like a section of industrial piping with a pistol grip welded to it. The other officers in the tent exchanged confused glances. One captain from the 509th Parachute Infantry had actually laughed, not mockingly, but with genuine bewilderment. "Sir, what exactly are we looking at?" "A rocket launcher. 5,000 of them are being distributed across the invasion force. The Germans have nothing like it. Neither do we, frankly. It was invented 6 months ago." Now, on the beach, Ridgefield watched as Corporal James Hutchins struggled to open one of the crates with a pry bar. The wood splintered, and inside, nestled in straw packing, lay 6 steel tubes, each about as long as a man's arm. Beside them were cylindrical objects that looked disturbingly like oversized firecrackers. "Captain, what the hell is this?" Hutchins called over the sporadic crack of rifle fire. Ridgefield jogged over, keeping low. He picked up one of the tubes, surprisingly light, maybe 13 pounds, and examined it. There was a wooden shoulder stock, a primitive wire sight, and what appeared to be an electrical trigger mechanism. "It's supposed to kill tanks," he said, hearing the uncertainty in his own voice. "With this?" Hutchins turned the tube over in his hands. "Sir, this looks like something my kid brother would build in shop class." He wasn't wrong. What neither of them knew was that the weapon they held had indeed been assembled from scrap materials only 18 months earlier in a testing ground thousands of miles away. Spring 1942. Aberdeen Proving Ground sprawled across the Maryland countryside, a landscape of firing ranges and testing facilities where the U.S. Army attempted to modernize an arsenal that had fallen dangerously behind European standards. On a muggy morning in early May, a small group of officers gathered in uncomfortable wooden bleachers to watch yet another demonstration of anti-tank weapons. The war in Europe had made one thing brutally clear: American infantry had no effective answer to German armor. The standard 37mm anti-tank gun required a crew of 6, weighed over 900 pounds, and had to be towed into position by a truck. Once emplaced, it was nearly immobile. Worse, its rounds barely scratched the frontal armor of newer German tanks. The British had offered their Piat, a spring-loaded spigot mortar that weighed 32 pounds and had a reputation for jamming at critical moments. 5 of them sat on the testing range that morning, attended by sweating crews who struggled to aim the ungainly weapons at a moving M3 Stuart tank 150 yards downrange. Colonel Harrison Caldwell sat in the front row of the bleachers, arms crossed, and watched the first Piat crew wrestle their weapon into firing position. It took them nearly 40 seconds just to adjust the angle. When they finally fired, the bomb arced through the air and landed 20 feet short of the target, throwing up a gout of mud. The second Piat jammed. The third misfired. The fourth and fifth managed to launch their projectiles, but both sailed wide of the moving target. Caldwell's jaw tightened. He turned to the ordnance officer beside him. "This is what we're supposed to give our boys? This is how they're supposed to stop a Panzer?" Before the officer could respond, a young lieutenant appeared at the edge of the testing range. He wore no service jacket despite the formal nature of the demonstration, just rolled-up shirt sleeves and a welder's mask pushed back on his head. Under one arm, he carried a length of steel piping. In his other hand, he held what looked like a large bottle rocket. His name was Lieutenant Kenneth Whitmore, and he had spent the previous night in the ordnance workshop with a civilian researcher named George Patterson. Together, they had built something that violated every principle of formal weapons development. There had been no contracts, no design committees, no approval from Washington, just an idea, a pile of scrap metal, and the certainty that American soldiers were going to die if someone didn't invent something better.
The steel tube had come from a reject pile. Seamless pipe, 2.36 inches in diameter, discarded because of a minor flaw that made it unsuitable for its original purpose. Patterson had spotted it 3 days earlier and measured it against the diameter of an experimental rocket he'd been testing. Perfect fit. The sight consisted of a piece of steel coat hanger that Patterson had bent with a pair of pliers into a crude aperture sight. The trigger mechanism was scavenged from a battery-powered ignition tester. The shoulder stock was carved from a block of wood in the base carpentry shop. Total construction time, 4 hours. Total cost of materials, approximately $7. Whitmore walked onto the range without fanfare. He didn't wait for permission or introduction. He simply positioned himself at the firing line, placed the tube on his shoulder, and looked toward the officers' bleachers. "Permission to demonstrate an alternative, sir." Caldwell waved a hand dismissively. "Make it quick, Lieutenant. We're already behind schedule." Whitmore turned back toward the target. The Stuart tank was still moving, following its prescribed route across the range. He sighted through the bent coat hanger, tracking the vehicle's movement. His thumb flicked a switch. He squeezed the trigger. The sound was unlike anything on the range that morning. Not the dull thump of a mortar or the crack of a rifle, but a sharp whoosh that turned heads across the facility. White smoke jetted from both ends of the tube as the rocket leaped away, leaving a thin contrail in the humid air. It took less than 2 seconds to cross the 150 yards. The rocket struck the steward's side armor with a metallic bang that echoed across the testing ground. The tank shuddered and stopped, smoke wisping from the impact point. In the bleachers, Colonel Caldwell stood up. Whitmore didn't pause. He dropped the empty tube, accepted a second one from Patterson, who had appeared beside him, loaded another rocket in 5 seconds flat, shouldered the weapon, and fired again. The second rocket hit within inches of the first impact point. The demonstration lasted 45 seconds from first shot to second hit. When the smoke cleared, Whitmore lowered the tube and turned to face the bleachers. He said nothing. The weapon spoke for itself. Caldwell descended from the stands and crossed the firing line in long strides. He took the steel tube from Whitmore's hands, turning it, examining the crude welds and improvised components. Then he did something that would become part of Army legend. He started laughing, not with derision, but with genuine amazement. "What in God's name is this thing made of?" he asked. "Scrap pipe, sir. Coat hanger. Some electrical components from the motor pool. We put it together last night." Caldwell hefted the tube. "It weighs less than a BAR. You're telling me any soldier can carry this?" "Yes, sir, and operate it with about 30 minutes of training." "What does it cost?" Patterson and Whitmore exchanged glances. They hadn't actually calculated it. "Materials?
Maybe $25, $30, sir? The rocket costs about $8. For a moment, Caldwell said nothing. He looked at the smoking steward downrange, then at the 5 PAT mortars whose crews were still struggling to reset their weapons for another attempt. Then he looked at the crude steel tube in his hands that had just scored 2 perfect hits in under a minute. He turned to his ordnance officer. "I want 5,000 of these in production by the end of summer. I don't care if you have to commandeer every steel mill from here to Pittsburgh. This," he raised the tube, "this is going to win the war." An aide appeared at his elbow. "Sir, what should we call it in the production orders?" Caldwell glanced at the tube, then smiled slightly. "It reminds me of that ridiculous thing Bob Burns plays on the radio. What's it called? A bazooka?" He handed the weapon back to Whitmore. "Call it that. The M1 bazooka." Within 3 weeks, the first production order went out to General Electric. Within 2 months, factory workers in Pennsylvania were welding together hundreds of tubes per day. Within 4 months, the first combat models were being packed in wooden crates and loaded onto ships bound for North Africa. Nobody told the soldiers how to use them. Nobody had time. Back on the Algerian beach, Captain Ridgefield and Corporal Hutchins had no knowledge of Aberdeen Proving Ground and Lieutenant Whitmore's demonstration. All they knew was that somewhere in the chaos of the landing, they were supposed to figure out how to use a steel tube to stop French tanks that were, at that very moment, maneuvering through the coastal hills to counterattack the beachhead. Ridgefield found a folded paper wedged in the bottom of the crate. Not a manual, but a single-page diagram showing basic assembly. No instructions, no firing procedures, just a sketch of a tube with arrows pointing to various components. "Get Corporal Briggs over here," Ridgefield ordered. "He used to work on cars before the war. Maybe he can make sense of the electrical parts." Briggs arrived, a stocky mechanic from Detroit with grease still under his fingernails from working on a landing craft engine. He studied the diagram, then examined the tube and the rockets. "Okay, I think I get it. This wire connects here, this hooks to the rocket's ignition, and when you pull this trigger, it completes the circuit, like a starter motor." "You think?" Ridgefield asked. Briggs shrugged. "Best guess, Captain."
They assembled one launcher as mortar shells began falling on the beach. The rockets themselves looked disturbingly simple, a warhead attached to a finned tube with an exposed electrical contact point. Briggs loaded one into the tube while Hutchins held it steady on his shoulder. "Now what?" Hutchins asked, his voice tight. "Now you point it at something and hope it doesn't blow up in your face," Ridgefield said. "That hill, there's a rock outcropping. Aim for that." Hutchins sighted down the crude wire guide. His finger found the trigger. He squeezed. Nothing happened. "Check the connection," Briggs said quickly. "Maybe the wire isn't—" Hutchins squeezed again. This time, the launcher bucked against his shoulder with a whoosh that made everyone nearby duck instinctively. The rocket streaked toward the hillside, trailing white smoke, and detonated 20 feet in front of the launcher, throwing up a fountain of sand and shell fragments. "Jesus Christ!" Hutchins threw the launcher down and scrambled backward. "That thing almost killed us." Ridgefield picked up the tube, checking for damage. It seemed intact, but his hands were shaking. He looked at the remaining rockets in the crate. "The ordnance is wet. It must have gotten soaked during the landing." Over the next 3 days, as American forces pushed inland, reports filtered back about the new weapon. The 509th Parachute Infantry Regiment attempted to use 20 rockets in combat. Only 7 functioned correctly. The rest either failed to ignite, detonated prematurely, or simply fell out of the tube and rolled on the ground like unexploded bombs. Soldiers began calling it the stovepipe, the drain pipe, or more colorfully, that piece of shit that's going to get us killed. In at least 2 documented cases, bazooka teams threw their launchers away and picked up abandoned German rifles instead. But on November 10, 1942, near the port city of Oran, something different happened. Sergeant Frank DeLuca of the 1st Armored Division had managed to keep his rockets dry by wrapping them in an oilskin tarp he'd scavenged from a supply truck. When 2 Vichy French Renault R-35 tanks approached his position, old, slow, but still armed with 37mm cannons that could shred infantry, he made a decision.
"Kowalski, get the bazooka," he ordered his assistant gunner. Private Leonard Kowalski stared at him. "Sarge, that thing doesn't work. We tried it yesterday and it—" "These rockets stayed dry. They'll work. Get it set up, now." They positioned themselves behind a low stone wall. The Renaults were advancing slowly, their commanders probably expecting only rifle fire from the American infantry. They had no idea what was about to hit them. DeLuca loaded the first rocket, checked the electrical connection twice, and shouldered the launcher. The lead Renault was 70 yards away. He could see the commander's head and shoulders protruding from the turret hatch. "Steady," he muttered to himself. He centered the wire sight on the tank's hull. He pulled the trigger. The whoosh was drowned out by the explosion. The rocket hit the Renault's side armor and detonated, punching through the thin steel in a shower of molten metal and fire. The tank lurched to a stop, smoke pouring from the impact point. The commander scrambled out of the hatch, his uniform on fire. "Load!" DeLuca shouted. Kowalski fumbled the second rocket into place. The second Renault had stopped, its turret traversing to find the source of the attack. Too slow. DeLuca fired again, hitting the second tank just below the turret ring. The explosion was catastrophic. The rocket must have penetrated into the ammunition storage. The Renault's turret blew off in a gout of flame that rose 30 feet into the desert air. For a moment, DeLuca and Kowalski just stared at what they'd done. 2 tanks, destroyed in less than 20 seconds, with a weapon they'd been issued 3 days ago and barely knew how to use. That night, the 1st Armored Division's after-action report included a single terse sentence. New rocket launcher proved effective against enemy armor when ammunition remained serviceable. Word spread through the American ranks. The bazooka could work. When the rockets were dry, when the connections were solid, when soldiers took the time to aim properly, it could actually kill tanks. But that same intelligence reached other ears as well. February 14, 1943. The red hills of Tunisia shook with the thunder of German artillery as Rommel launched his counteroffensive at Kasserine Pass. American units, many of them green and poorly positioned, broke under the assault. The Second Corps retreated in disorder, leaving behind trucks, artillery pieces, medical supplies, and 5 intact M1 bazookas with approximately 20 rockets. Oberleutnant Werner Hoffmann of the Afrika Corps found them while sweeping a captured American position. At first, he thought they were some kind of signal equipment. The crude construction, the exposed wiring, these didn't look like weapons. But when he examined the rockets and saw the shaped charge warheads, he understood what he was holding. Within hours, the captured bazookas were on a transport plane to Berlin. Within a week, they arrived at the Kummersdorf Proving Ground outside the German capital.
The analysis was conducted by some of Germany's finest ordnance engineers. They disassembled every component, measured every dimension, tested the electrical systems, and fired the captured rockets at armor plates of varying thickness. Their report, filed on February 28, 1943, made sobering reading for the Wehrmacht High Command. The American rocket launcher represents a fundamental shift in infantry anti-armor capability, the report began. Construction is extraordinarily simple. Seamless steel tubing, minimal electronics, no precision machining required. Weight, 6 kilograms. Effective range, 100 to 150 meters. Penetration, 80 millimeters of armor plate at 90-degree angle. Production requirements, minimal. Any industrial facility with basic metalworking capacity could manufacture this weapon in quantity. The implications were spelled out in stark terms. If the Americans could equip every infantry platoon with these launchers, and the simplicity of design suggested they could, then German armor would face rocket-armed infantry on every front. The panzer divisions that had terrorized Europe with their speed and firepower would suddenly be vulnerable to foot soldiers carrying weapons that cost less than a bicycle. At a meeting in the Reich Chancellery, General Hans Guderian reviewed the Kummersdorf report and made a decision. We must have our own version immediately, and it must be superior to the American design in every way. The German response came with characteristic thoroughness and over-engineering. Instead of simply copying the bazooka, Wehrmacht ordnance designers scaled up the concept. They increased the rocket diameter from 60 millimeters to 88 millimeters, the same caliber as the fearsome 88 millimeter anti-aircraft gun that had proved so deadly against Allied tanks. The result was a shaped charge warhead that could penetrate 160 millimeters of armor, double the bazooka's capability. But power came at a price.
The German weapon, designated Raketenpanzer 43 and quickly nicknamed Panzer Shrek, or Tank Terror, by the troops, weighed nearly 20 pounds empty. Its firing signature was massive, a jet of flame and smoke that could incinerate anyone standing too close to the rear blast. Operators had to wear a heavy protective face shield to avoid being burned. Production began in September 1943. By the end of the war, German factories would produce 289,151 Panzer Shreks, an impressive number that would nonetheless fall short of American bazooka production, which exceeded 476,000 units. More importantly, each Panzer Shrek required significantly more manufacturing time, more raw materials, and more skilled labor than a bazooka. At a time when Germany was struggling with resource shortages and Allied bombing campaigns, this difference mattered. A German ordnance report from late 1943 acknowledged the problem. While the RPG B-43 demonstrates superior anti-armor performance, production capacity cannot match Allied output. The enemy weapon's simplicity enables mass manufacture at rates we cannot sustain. The industrial mathematics were brutal. For every Panzer Shrek Germany produced, American factories turned out nearly 2 bazookas. And while the Panzer Shrek was theoretically more powerful, the bazooka was more than adequate to penetrate the side and rear armor of most German tanks, and there were twice as many of them on the battlefield.
July 10, 1943. The island of Sicily shimmered under a merciless Mediterranean sun as Allied invasion fleets converged on its southern shores. Operation Husky, the largest amphibious assault yet attempted in the war, brought 160,000 troops crashing onto beaches defended by Italian coastal units and German mobile reserves. Among the American forces came a weapon that was no longer an experiment. The M1A1 bazooka had arrived. Unlike the moisture-damaged rockets and untested launchers of North Africa, these weapons had been refined through 8 months of combat feedback. The electrical contact points had been redesigned to resist corrosion. The M6A1 rocket featured improved waterproofing and more reliable propellant. Most importantly, soldiers had actually been trained to use them. Not extensively, but enough to understand loading procedures, electrical connections, and basic aiming principles. Corporal Vincent Mancini of the 82nd Airborne had received only 2 days of training on the weapon before the invasion. His instructor's advice was blunt. This thing will save your life if you know how to use it. Moisture is your enemy. Check your electrical contact before every shot. And for God's sake, make sure nobody's standing behind you. 3 days after landing near Gela, Mancini found himself facing the Wehrmacht's most feared weapon, a Tiger I tank. 60 tons of steel with 100mm frontal armor, virtually impervious to American anti-tank weapons. Lieutenant Kavanaugh crawled beside him with an impossible order. Hit the driver's vision port. If you can blind it, the tank can't fight. The odds of hitting a 6-inch slit on a moving tank at 140 yards were astronomical. Mancini had qualified by hitting stationary targets at 50 yards. But watching the Tiger advance toward the crossroads where it could slaughter American troops who had no defense, he loaded a rocket and fired. The shaped charge explosion blew fragments into the driver's compartment. The Tiger stopped, engine running but motionless. Within minutes, the crew abandoned it and the entire German force withdrew. That evening's after-action report noted simply, M1A1 rocket launcher disabled Tiger I tank. Weapon effectiveness confirmed. The report didn't mention the 1 in 1,000 luck involved. It didn't need to. Word spread through both armies. A bazooka team had stopped a Tiger. German tank commanders who had grown accustomed to infantry scattering at their approach now had to consider that any cluster of buildings might conceal rocket teams. The easy confidence of armored warfare was being replaced by caution. By August 1943, American forces had used bazookas to destroy 17 German tanks in Sicily. More importantly, they had fundamentally altered the infantry-armor relationship. As Colonel James Rutherford wrote,
Our soldiers no longer fear tanks. They hunt them. December 1943 brought new revelations in Ortona, Italy, a medieval town that became Little Stalingrad during brutal house-to-house fighting. Canadian forces faced German soldiers who would fortify every building. Advancing down streets was suicide. Artillery created more rubble defenses than it destroyed. Sergeant William Mackenzie of the Seaforth Highlanders found the solution by accident. Pinned down with a bazooka meant for anti-tank work, he looked at the 3-foot stone wall separating his position from German machine gunners and asked, "What happens if we shoot through the wall?" His gunner thought he had lost his mind, but anti-tank meant punching through armor, and armor was harder than stone. They fired. The explosion left a ragged hole 3 feet in diameter, large enough for a man to crawl through. Within hours, mouse-holing spread through Canadian forces. Instead of fighting street by street, troops moved building to building through bazooka-blasted walls. German defenders expecting attacks from doors and windows found themselves flanked through interior walls. The bazooka had evolved from anti-tank weapon to general-purpose assault tool. In Italy's mountainous terrain, it became pocket artillery, allowing small units to bring heavy firepower without waiting hours for artillery support. By early 1944, each infantry battalion was authorized 24 to 36 bazookas, making it as common as the Browning automatic rifle. For German forces, this proliferation created a tactical nightmare. Wehrmacht Directive 43-18 reflected the changed reality. Armored vehicles will not operate in urban or close terrain without dedicated infantry support. Enemy rocket weapons have made independent tank operations untenable. It was an admission that would have been unthinkable when panzer divisions were racing across France and Russia. The blitzkrieg doctrine of rapid armored thrusts without infantry support had become obsolete.
June 6, 1944. Operation Overlord brought the latest evolution, the M9A1 bazooka, featuring a 2-piece design for easier transport, improved magneto-ignition, and better optics. American factories had manufactured 277,800 launchers by D-Day. The bocage country of Normandy, ancient hedgerows dividing the landscape into small fields, proved ideal for bazooka teams despite seeming like a nightmare for attackers. The hedgerows provided concealment and cover. Short ranges played to the bazooka's strengths. German tanks advancing slowly through confined spaces gave teams time to set up ambushes. Private Raymond Kowalski's first encounter came on June 9th when a Panzer IV appeared in an apple orchard. At 70 yards, he aimed for the thinner side armor and fired. The tank lurched to a stop, smoke pouring from below the turret ring. The crew bailed out rather than risk staying in a crippled vehicle. Over 6 weeks, scenarios like this played out hundreds of times. First Army analysis revealed that bazookas accounted for 12% of German tank kills in the American sector. That number didn't include tanks abandoned when threatened, a phenomenon German reports mentioned with increasing frequency. The democratization of anti-armor capability was complete. American infantry no longer needed to wait for tank support or tank destroyers. They carried their own anti-tank weapons and used them with growing confidence. December 16, 1944. The Battle of the Bulge tested the bazooka under the worst possible conditions. Sub-zero temperatures killed batteries within hours. Rocket propellant burns differently in extreme cold. Some rockets refused to ignite. Staff Sergeant Donald Halbrook improvised solutions, warming rockets over small fires before loading, wrapping batteries in wool socks against his body, waiting until German tanks were practically on top of his position, 30 to 50 yards, where even degraded accuracy was sufficient. On December 17th, he destroyed or disabled 3 Panthers. The third kill came at 25 yards, close enough that he could see the German tank commander's face. The 99th Division credited bazooka teams with destroying or disabling 89 German tanks during the Ardennes campaign.
Many kills came at suicidal ranges, but in winter's limited visibility, close-range ambushes became the norm. Meanwhile, Major Charles Carpenter was proving the bazooka could work in an environment nobody imagined: the sky. Flying an unarmed L-4 Grasshopper observation plane, Carpenter mounted 6 bazooka launchers on the wing struts and rigged a cockpit firing system. On September 20, 1944, he spotted 2 Panthers, dropped to 500 feet, and fired. Both tanks stopped, smoke pouring from their engine decks. By war's end, Carpenter had destroyed 6 German tanks from his fabric-covered plane. Rosie the Rocketer proved that American innovation could transform a weapon designed for one purpose into something entirely different.
In the Pacific, the bazooka faced different challenges. Japanese armor was lighter and more vulnerable, but Japanese defensive tactics, turning every island into a fortress of bunkers and caves, created new problems. On Saipan in June 1944, Marines destroyed 28 Japanese tanks with bazookas. But the real value came in anti-fortification work. The shaped-charge warhead designed to penetrate tank armor proved equally effective against concrete bunkers. The M10 white phosphorus rocket, developed for the Pacific, turned the bazooka into a multi-purpose weapon. Against caves and bunkers, it created smoke screens and incendiary effects, forcing defenders out of positions even if the explosion didn't kill them. At Iwo Jima in February 1945, American forces fired 1,847 bazooka rockets during the 36-day battle, 60% anti-tank rounds, 40% white phosphorus. The weapon had become the Marines' most versatile infantry support tool. By war's end, the transformation was complete. What began as a makeshift anti-tank weapon had become one of the most versatile weapons in the American arsenal, fundamentally changing infantry combat. The cost analysis was striking. Destroying a German tank with an American tank required 2.5 Shermans lost, roughly $187,500 in equipment. Aircraft kills cost approximately $85,000. A bazooka team typically used 5 rockets and sometimes lost the launcher. Total cost? About $50. For the price of 1 Sherman tank, the Army could purchase 3,000 bazookas and 20,000 rockets, enough to equip dozens of infantry battalions. The bazooka demonstrated a distinctly American approach to warfare. Instead of creating sophisticated, expensive weapons in limited quantities, produce simple, cheap weapons in overwhelming numbers. Instead of restricting powerful weapons to specialized units, democratize capability by giving every infantryman the potential to threaten enemy tanks. Field Marshal Kesselring stated during post-war interrogation, "The American rocket launcher forced fundamental changes in how we employed armor. Speed and shock tactics became untenable when infantry could destroy tanks at close range. We had to slow down, proceed with caution. This negated our primary advantage." Even Heinz Guderian, architect of Blitzkrieg doctrine, acknowledged that personal anti-tank weapons like the bazooka had completely negated the independent use of tanks and forced a return to combined arms tactics that reduced armor's effectiveness. Through Lend-Lease, over 60,000 bazookas reached Allied forces worldwide, spreading American tactical philosophy. The weapon became the template for post-war infantry anti-tank weapons, from the Soviet RPG series to modern systems like the AT-4 and Javelin. Today, the bazooka exists primarily in museums, but its legacy lives on in every squad-level anti-tank weapon, in every doctrine emphasizing infantry initiative and distributed capability, in every military choosing simplicity and numbers over complexity and scarcity. At 20 meters, in a frozen Belgian forest or Sicilian town or Norman hedgerow,
The bazooka proved that in modern warfare, the side that could put powerful weapons in every soldier's hands would ultimately prevail. The sophisticated and rare had lost to the simple and plentiful. The blitzkrieg had been stopped by a $25 steel tube. And that truth, forged in combat from North Africa to the Pacific, would shape warfare for generations to come. Up next, you've got two more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.